Thank you. I'm still waiting for the brain-computer interface where I just think, next slide, and it goes. But that's for the future. Actually, they exist, you know. People have been doing that to type since the 80s, but I'm getting off topic. So thanks, everyone, for your patience for kind of me being on stage again here. And in this talk, I'm going to drill in just a little bit to a particular use case, and one that actually affects all of us as well. And let's get started. The title is A New Data Economy with Power to the People. And one kind of aside, you'll see there's lots of jellyfish in these slides. I've discovered that I asked myself the question, if AI were an animal, what animal would that be? And I realized that it's really jellyfish, and they're kind of an amazing creature. So let's get started. The dream, and more jellyfish, right? For a long time, going back to the 50s and before, there was this dream of a decentralized, open, free flow of data, right? And in this dream, we had everything from the initial ARPANET, leading to the internet, leading to the World Wide Web, and so on. It was always, always, always about this free, open flow of data. The picture you see here is Tim Berners-Lee, shortly after he invented the World Wide Web out of CERN in 89-90. And this was a wonderful dream, and you know, we have the web, this sort of one giant single document for the planet. But issues have arisen. And the root of it, unfortunately, relates to data and AI. This slide kind of summarizes it. It's sort of a nerdy way of summarizing. But to give a story, when I was working for National Defense in the 90s, my very first task there was I was given a data set of 20,000 points. And my goal was to improve the accuracy to classify audio radar for tanks. And my initial cut, very silly linear regression and whatnot, gave me 45% error. And my whole job was to try to improve the error. So I spent a summer at it. And by the end of the summer, I was down to, I think, 25% error. So I improved error by 20%. But still, 25% error means 1 in 4 times it fails, right? Terrible. And basically, I didn't have more data. I just had fixed data. But what happened, you know, these Microsoft researchers in 2001, and then other researchers throughout the 2000s discovered, why iterate on, you know, with PhDs iterating on fancier and fancier algorithms? You can do that, but it's kind of unreliable. It takes time. Rather than that, what about just adding more data? So this slide shows that as you add more data, that's the x-axis, more and more millions of words in this case, the accuracy goes up. In this case, going from, say, 75% error, 25% error on the far left, up to 99% accuracy or 1% error, right? And it didn't even matter which algorithm you used. In this case, it showed 4 different algorithms, and they're all about the same, right? And in fact, the simpler the algorithm, the better it did when there was more data. And we had, you know, more than 1,000x more data. It reduced the error by more than 1,000%, right? This is actually pretty embarrassing to AI people like me, because we like to say that we've got lots of value for like inventing our new algorithms, right? But it means that actually you can start to mechanize AI improvements themselves. And deep learning took this to the next level because it improved the UX. It improved the UX for building accurate models. You just throw in a lot of data, you have lots of compute, and you're good to go. But what this has led to is, well, people farming, like I mentioned before. You have the Googles and Facebooks and Amazons of the world where their goal is to gather more and more and more data with more compute, which gives them better models with more accuracy. From that, they can sell more ads and make more money, right? This is the status quo. And the problem is, they realize that to maintain the status quo, they have to silo it. They have to keep it to themselves. So while they call themselves AI companies, they really are data companies. AI is a head fake. They are gathering data and putting up walls. Google buys satellite imaging companies. Facebook buys data from more than 150 organizations just to basically track you and mine you better. This actually is very dangerous for society and freedom itself, as you might imagine. To summarize with this, Google and Facebook, just 2 companies, now have direct influence over 70% of internet traffic. This was an essay that came out about a month ago, got a lot of virality. The title is telling as well. The web began dying in 2014. So we have these data silos, or call them people farming. Every time you go into Google, every time you go into Facebook, you are being surveyed, and they are making billions off you. How do you feel about that? You can summarize this problem. My friend Lawrence summarized it the following. The core problem is that you have siloed data with no economic incentive to share. And that's really 2 problems coupled, the siloed data part and the economic incentive part. I'll drill into each. About how do we solve it? First, how do we break down the silos? Well, if you think about it, Facebook and Google and a handful of others are the exceptions to the rule. They have both the data and the in-house AI expertise. But most large enterprises have lots of data. They don't have the in-house expertise because the AI experts are off starting their own companies, trying to get wealthy their way. But those companies are actually starving for data largely. I know this. I've lots of friends in AI world. I've been in that world myself for many years. So you've got these you've got the supply side and the demand side. Folks with lots of data, folks needing lots of data, and they're not really that well connected. But what if they could somehow pool their data, where you have a really great medium of communication for them to talk from A to B? Well, that's where data marketplaces come in, and they are taking off now, right? This is not a new thing. They've been taking off for a few years, bit by bit by bit. One large data marketplace got bought a couple years ago for more than $1 billion by Oracle. So you can have these data marketplaces, right? A challenge is that they themselves can be centralized, right? Just like if I put my digital art into a store that's centralized and they're selling on my behalf and they have me locked in, what if they go corrupt? What if they go broke? All of that. This is a challenge with the centralized data marketplaces. So you really want a lot of them, and ideally each of them having your data. But do you want to enter your data into every single one of those? Imagine if you could enter your data into just one marketplace, and there's a substrate below that where that data is being stored, or at least the keys to it are being managed in a way where you can control your data, who buys it, how it gets sold, and so on. And then there's these marketplaces on top to help you to buy and sell it. This exists, actually. There's a precedent in the airline industry. Sabre and Amadeus. Sabre and Amadeus are two databases basically coupled together that hold all of the data of the different airlines together. You've got American Airlines, you've got United Airlines, you used to have Air Berlin and all of this. And then they pool their data, and then it's made available on AmericanAirlines.com and Kayak and Expedia and Hipmunk, etc. Right? So you have all these different user interfaces and focuses on top, but you have a universal data substrate below. And in the case of Ocean, it's like Sabre or Amadeus, except it's not just for airline data, and crucially, it's decentralized. So it is helping to unlock, the goal is to unlock a new data economy. On the second problem, the economic incentives, what can we do about that? Well, in the beginning, there was Bitcoin. We talked about that, right? And under the hood, you might ask, well, we know there's blockchain under Bitcoin. It's got decentralization and mutability. It aligns incentives. You can do these crazy ICOs. But is that the most amazing thing? There's one that's actually not talked about as much, and I think it's the most amazing one of all. You can get people to do things. If you set up the right incentives, and then you bake those incentives into the network as block rewards. This is exactly what Bitcoin does. It has an economic incentive saying it wants to maximize the security of the Bitcoin blockchain. How? Well, it defines security as compute power going in. And it makes it so that it's super expensive computationally to roll back changes to the transaction log to make it immutable, right? So it's got this overall function which basically says the rewards you get are proportional to the hash power you're putting in, the security that you're putting in. I can summarize this as you get block rewards if you're running a full node and you have gobs of compute power, right? So every 10 minutes, if you've got enough compute power, you might get some of those bitcoins that come out, 12.5 bitcoins. So the summary here is that Bitcoin is getting people to do stuff. In this case, it's getting people to build giant data centers like the one above just to do this hashing to secure the Bitcoin network in this case. But we can do our own incentives for a data substrate, for what we call Ocean. What is it? What we're trying to do is maximize the supply of high-quality, curated data. This means rewarding curated data and making it available, those two things. And the rewards then are proportional to the popularity of the data and how much you've bet on it, how much you've staked it. To make that simpler, you get block rewards in Ocean if you've bet on a data set, early especially, and you make it available when asked. And then the block rewards come out. So just like Bitcoin, you're running a full node and you're doing hashing in this case, you bet on data and you're making it available. That's the mining. And therefore, of course, it's also not using all the electricity of Ireland, like Bitcoin. Like any blockchain network, it's got a bunch of nodes that run. It's got building blocks in between. Like I talked about before, one of the target use cases is self-driving cars, like Toyota Research. We built a prototype with Toyota early this year called AVDex. And ever since then, we've been working with them to develop and work with more automakers. So a couple benefits that this unlocks, and then to the conclusion. It equalizes the opportunity for access to data. It democratizes the data for everyone, as well as the benefits of AI, because benefits of AI get unlocked by data. How this benefits then is squeezing out the data silos. We no longer have to be people farmed. It means that your health data, if you choose to share it, you can share it with the scientific researchers of the world. So if I'm a researcher, rather than just having a small data set of 1,000 data points, I might have 10,000, 100,000 or more. I can build way better models to do things like detect Parkinson's much earlier. And we actually have a project related to this with some partner companies. Self-driving cars, I've talked about that. Fewer accidents, more mobility. So, to summarize, we've lost the web, the dream of the web. But we have the opportunity to reclaim it better than ever. Let's reclaim it by building a new data economy and give power back to the people. Thank you.